to the third part of our lecture. So, dito nag-stop sa table. So, on this table, kung nakay duha ka grupo around the central atom, that means nakay duha ka sp orbital. So, for three surrounding groups around an atom, that is nakay tulo ka sp3 orbitals. Okay, ang nagamit. So, when there are four groups around an atom, the number of orbitals used will be 4 and there will be 4 sp2 orbitals. So for example, it's HF, hydrogen fluoride. How many groups? There are 4, 1 hydrogen and 3 lone pairs. So therefore, ang iyang arrangement or yung geometry is tetrahedral. Okay, so there will be an overlap of 2 sp3 and 1 s. Ganong 2 because okay, so there sa HF molecule na siya, diba, tulo ka lone pairs. So these lone pairs are actually in the sp3 orbital. And sa HF, na overlap of 2 sp3 and 1 s. What do you mean by 2? That is not duha ka sp3, but this pertains to the shell, to where this sp3 belongs, because fluorine has a fluorine diba has an atomic number of 9, so therefore it has 9 electrons. So ang iyang electronic configuration is 1s2, 2s2, and 2p5. So this is what is meant by this 2. Okay, so kung i-compare na to ang bonding between HF and HCl, na difference actually, because ang overlap of the 2 sp3 of F and the 1s of the hydrogen. So kung compare nimo ang HF and HCl, ang overlap sa HCl is between a 1s of the hydrogen and the 3sp3, because diba ang chlorine, kung imo siyang i-write ang electron configuration, maabot siya sa ikatulo nga shell. So mo na yung molecular orbital representation. So meaning aning kani siya orbital nga molecular orbital is that there is a greater electron density here as compared to this one. Okay, there is a lesser electron density kay it is spread over a larger area. So there is smaller area man, so meaning ma-concentrate ang electrons dere as compared dere. And natingala mo nganong mas gamay man ang overlaps with when you have fluorine versus chlorine. And that is where the atomic size, a property of each atom, comes in. So sa periodic table, guys, di ba, nani man ang itsura na carbon, nitrogen, oxygen, fluorine, and down the column you have chlorine, bromine, iodine, and astatine. Okay, so as we go down the periodic table, the atomic size increases. Okay, meaning to say, si iodine mas dako siya size kaysa kay bromine, si bromine mas dakong size kaysa sa chlorine, si chlorine mas dakong size kaysa kay fluorine. So therefore, kay mas dako mag-size si chlorine, ang iyang distance, oh god, if this is the hydrogen and this is chlorine, okay, so i-compare nimo sa fluorine, no? Imagine this is the nucleus, ha. So kung lahion nato ang bond, remember na pag measure sa bond length is from nucleus to nucleus. Whereas kung HF, diba, mo na siya nga mas gamay ning overlap dire compared sa chlorine, pero greater ang electron concentration or electron density dire sa HF. And kung nagay greater electron density, there is more overlap or there is effective overlap, and this is a stronger bond. It is difficult to break this bond kay densely populated ang yung orbital with electrons as compared sa HCl. Okay, So when we talk about um, hydrogen halide bond lengths and bond length, down this is down the table, down the column na. So down the column, your bond length increases, but your bond strength decreases. Always remember nga, the smaller the size of the atom, um, kung sa halide, mas strong ang iyang bond, kaya mas mabuo siya. Ang internuclear distance, there is effective overlap. So, um, um, what happens across the row in the periodic table? Okay, as you can notice, the atomic, uh, the bond length decreases, right? Decreases. So, but the bond strength increases. This is because ang atomic size is also decreasing. Atomic size is decreasing. That is why ang bond strength is increasing. It is a stronger bond. HF has a stronger bond than CH, okay, and CHN and HO. So the change is not as dramatic as you move across the row, but as atomic size decreases, bonds get shorter and get stronger. Always remember that the shorter the bond, the greater is and the greater is the bond strength, and the shorter is the bond. Okay. So relative bond length and bond strength of bonds in ethylene and acetylene. So this is just a comparison. Okay, this table, makita imong pattern. So important points. A double bond is stronger than a single bond, but not twice as strong. Okay? Pi bond is weaker than a sigma bond. So ako na nang mention kanina. Why? Because sideways overlap is not as good as end-on overlap. Okay? And I will introduce to you the concept of S character for hybrid orbitals. Hybrid orbitals meaning sp, sp3, and sp2. So the closer to the nucleus and the more tightly held are its electrons. So s orbital mas close siya kaysa sa electrons, no? So there is no node actually, but for p orbitals there is a nodal region here. Na wala electron density dere or wala kayo makita ng electron. So for sp3, ang iyang s character meaning ang characteristic niya nga duol siya sa nucleus because it is described as if it is an s orbital. So the more the s character, the more electrons are held closer to the nucleus. Meaning to say, kung mas taas ang s character sa isa ka molecule, sa isa ka bond, meaning ana is strong siya nga bond, and mas duol siya sa nucleus of some certain atom. Okay, so for sp3, s character is only 25%. For sp2, s character is 33%, while for sp, the s character is 50% because this is 50% s and 50% p. Okay, so inana ang iyahang concept. Okay, so therefore the bond strength increases as you go down, meaning to say sp or hybrid orbitals are stronger than sp2 and sp2 are stronger than sp3 bonds. Okay, so if we compare the sp3, sp2 and sp bonds, mas dako ang sp3 and pinakagamay si sp. So di ba yung nang-mention ko ganyan sa HF molecule, kung gamay gali ang molecular or ang hybrid orbital, meaning ana is there is more electron density in that orbital, and in other words, it is a strong orbital as compared sa kanang mga dagko nga orbital, because sa mga dagko nga orbital like sp3, the electrons are spread over a large area, okay, making it weaker. So the length and strength of a CH bond depends on the hybridization of the carbon atom it is attached to. So for sp3ch bond, mas longer siya and weaker because there is less S character as I mentioned a while ago. But for SPCH bond, it is stronger and shorter because there is more S character. sp3ch bond, example kana. Ang SPCH bond, uh, ano eh, this is an SPCH bond. Mas greater ang bond strength ani mo nang lisod ni siya i-break. Okay, so a CH sigma bond is shorter and stronger than a CC sigma bond. Okay, because the s orbital of the hydrogen is closer to the nucleus, therefore CH is stronger and is shorter and a stronger bond because CH has sp3 and s orbital interaction while CC bond has both sp3 interaction. Always remember that the greater the s character of the orbital, the larger is the band angle. So we now go to electronegativity and bond polarity. So bonding electrons shared equally, both atoms have the same electronegativity. An example is the hydrogen molecule, that is a nonpolar covalent compound, or it has nonpolar covalent bond. While for polar covalent bonds, an example is HCl. Na-different akong diferensya ng electronegativities. Paki-search na lang sa periodic table sa ilang electronegativities, but you will always encounter na kung i-minus nimo ang electronegativity sa Cl and H, it will fall under polar covalent bond. Okay, so shared electron pair is closer to chlorine because it is more electronegative than H. So what is electronegativity? Electronegativity is the ability of an atom to attract electrons towards itself. So between H and Cl in hydrogen chloride, si Cl ang mas electronegative compared sa H. So that's why the greater kani siya mga electrons, guys. Kani this spends more time here for Cl than H because Cl is more electronegative. It attracts the electrons of the hydrogen towards itself. Okay, so we chemists in the chemistry profession or in the chemistry science, we often denote this delta plus when the molecule is electropositive, and kung electronegative gali, it is represented by a delta minus or ganito. So the more atom is electron rich, it has a partial negative charge, and if the atom is electron deficient, it has a partial positive charge. And we often denote bond polarity by this vector. Mura siyang arrow nga nanan siya yani ana, and ang head sa arrow nakapoint siya sa atom nga mas electronegative. Okay. So the greater the difference in electronegativity, the greater the polarity of the bond. So for sodium and chlorine, a metal and a non-metal, it is an ionic bond. Just compute for the electronegativity difference. Okay, so for C and H, the difference is quite low, 0.3 lang ang electronegativity difference. It is therefore non-polar covalent bond. And for the rest of these compounds, it is covalent bonds with high polarity. Remember that electronegativity difference is greater than, if the electronegativity difference is greater than 1.8, the electron will be transferred completely and you will have an ionic bond. But an exception to this is HF, because HF is proven to be not ionic even though more than 1.8 ang iyang electronegativity difference. Okay, so we also often denote the compound or describe a compound in terms of what we call electrostatic potential maps. Kani siya. More on mapicture out ni mo siya ang iyahang electron density, no? So mao ni siya ang legend. So kung pula gani, this is the color gradation. Kung pula gali, kung asa ang pula dito ang electron rich, okay, nga region. Kung electron poor naman, that is indicated by blue. The blue ones, electrostatic potential map, or the EMP. So I have here an example. So methyl chloride, mo ni siya ang iyang lowest structure. Ano siya? So di ba chlorine is the most electronegative atom among the atoms in the molecule. So therefore it has delta minus. Okay, and electrons are concentrated here sa chlorine. That is why pula, if this is chlorine, carbon H, H, H. That is why the pula ni siya dire. Kay electronegative makay si chlorine, gina-attract niya yung electrons from carbon and hydrogen. And another example is hydrogen fluoride. This is the H and this is the fluorine. So between the two, fluorine magid ang pinaka-electronegative. So therefore, mas pula kayo diri sa fluorine. Okay, so diri naman sa NH3, ammonia, ang na siya lone pair, diba? So mo na ang kaning pula nga portion, mo na yung N, ako na lang siyang i-block. Mo na yung N, mo ni ang uh, uh, hydrogen, hydrogen, hydrogen. But the lone pairs here, kani lone pairs, diri ang region wherein taas o density sa electron. So mo nang diri ang pula. Same po sa carbon ayon nga na siya negative charge. Okay? So sa water naman, ang iyahang electron density indicated by the red is concentrated on the lone pairs. Same is true for the hydroxyl ion. Ang electrostatic potential map shows na ang red nga portion na siya sa oxygen. Okay, because oxygen is more electronegative than hydrogen. And lastly, for the hydronium ion, which is H3O plus, okay, this is the oxygen, this is H, H, and H. Okay, so oxygen being more electronegative atom, sayagid ang pula sa EMP because naman po kay electron pair dere bisan pag positive charge na siya. So a polar bond has a dipole. Okay, it has a negative end and a positive end. It acts like a magnet. So the size of the dipole is indicated by the dipole moment. I will not go over this because I will not even include this in the exam. Okay, so just read on this kaning dipole moment. So so on this table, this what is indicated in this table is the different dipole moment between these bonds, specific bonds, CN, CO, CF, CCl, CBr, CI. Okay, so there are some things that we need to consider though. So kaning si CCl and versus CF, kaning si CCl, it has a larger dipole than CF, even though F is more electronegative. Okay, the more maganda electronegative ka, mas you are becoming a dipole wherein there's an imbalance of charge. Okay? And CO dipole is smaller than a C double bond O, even though C double bond O is shorter. Okay, why? Because it is the magnitude of the charge difference times the distance. Kani siya nga formula, but don't bother about it. Okay, so CF has greater charge but is a shorter bond than CCl. Okay, so we now go to polarity of molecules. As I mentioned before, that we often draw this vector when we describe polarity. So some examples for carbon dioxide, one way to identify. Okay, so in okay, so in chemistry we often denote polarity by this vector, right? So I will give some examples on how to determine if a molecule is polar or not. So first example is carbon dioxide, and it is drawn, the Lewis structure is drawn like this one, and between C and oxygen, the more electronegative between the two is oxygen, so therefore the polarity is directed towards oxygen. And since this is the structure, so the polarity cancels out, so meaning the dipole moment is zero, and the overall there is no dipole, so carbon dioxide is not polar. So for boron trifluoride, um, we all know that fluorine is the most electronegative element, so the polarity will be directed towards fluorine, and there are 3 bonds of fluorine, so the vectors also cancel tulo, because when you recall in physics, when you add any two vectors, the resultant vector will be equal and opposite the remaining vector, therefore the dipole is 0, the dipole moment is 0, and it is not polar. Okay, then I have drawn the resultant vector. So for the carbon tetrachloride, the vectors cancel in 3D space. When you add any 3, the resultant vector is equal and opposite the remaining vector. Okay, na naman, yan siya. You drew it like this, like this, like this, and like this. Okay, so this 2 will cancel, and this 2 also will cancel, therefore the dipole moment is 0, and carbon tetrachloride is non-polar. Okay, even though non-polar ni sila, they have polar bonds because they ang groups nga nata sa central atom are electronegative. You can always account for the electronegativity difference, but non-polar sila because the polarity of the bonds will cancel, leading to a 0 dipole moment. Okay, so I will also introduce to you or share with you some polar molecules. This one is formaldehyde. Okay, so the polarity there is directed towards oxygen, and therefore there will be no um, um, the CH polarity will be like this, drawn like this, so there will be no cancellation of bond polarity as indicated by the vector arrow, so this is polar. And also for the ammonia, ang bond polarity is drawn like this, also there will be no cancellation of the dipole, and ang net dipole is diri sa towards sa tunga, there is a lone pair sa ammonia. Okay, one net dipole, therefore ammonia is polar. And sa dichloromethane, so ang polarity is towards chlorine, and the resultant vector or the resultant bond polarity vector is directed away, so they will not cancel each other out, so the net dipole indicates that dichloromethane is polar. Okay, so this is the last page or the last lecture, the last part of our lecture for structure and bonding. I know that this is quite a long lecture, and for all you know, the main reason is because it is important for all of you guys to know the fundamentals of organic chemistry para understanding you better higher topics of this subject. So if you want some additional readings or learning intervention, you may opt to click these links below, and that will be all, and take care, and thank you for so much for listening. Okay.